All right, so if you guys read the instructions in the first two problems, it's asking us to simplify the following expression. So whenever they're asking you to simplify, they're not asking you to solve for anything. They're asking you just to make what you have look simpler by combining like terms and pretty much performing whatever mathematical operations are possible. Now, I can see here that I have something in parentheses plus something in parentheses. So I know I need to add those two things. Now, the parentheses there are just there to visually show you, hey, add this plus this. Now, before we start adding the like terms within those actual parentheses, let's see if there's anything to distribute in front of the parentheses. Now, is there anything to distribute there? No, right? So what I like to do is I like to just rewrite it so that way I can visually get those parentheses out of the way. And then I go on to my next one. And I notice here that there is a positive, but if I were to distribute a positive, nothing absolutely changes. So I'm just going to go ahead and rewrite whatever was in the parentheses without parentheses. So that way I get those visually out of the way, and now it's my turn to pretty much combine like terms. Now remember, in order to combine like terms, you need to know what a term is. And a term are two things that are getting added or subtracting, or more than two things really. So notice that it's what I did there is put a line underneath everything that was getting added or subtracted, so that way I could focus on the terms. And now I need to look for the terms that have the exact same variable with the exact same exponent. And I can see here that I have a 5b to the 4 and a 5b to the 4. So since those both have b to the 4s, those are like terms. You can add those. And what is 5 plus 5? Well, it'd just be a 10. Don't forget your b to the 4th. Now I have to remind you guys that you are adding here. You're adding something b to the 4 plus something b to the 4. So I have 10 b to the 4s. My variable and my exponent don't change at all. So let me cross those out. I'm going to go on to the next one. Now I can see that I have b to the 3s, so those are like terms. I can combine them. Now that's a 7, that's a negative 8. 7 minus 8, or 7 plus a negative 8, is a negative 1. Now, is it really necessary to have my negative 1 there? No, right? Because it's unnecessary. I'm not going to mark you right or wrong, or I'm going to mark you right, but not wrong. So with that being said, this would be your final answer. Keep in mind that your terms are in order from degree, aka from least to greatest exponent. Pretty good reminder? Good. All right, very next one, just to speed things up there. I have something minus something, so I'm finding the difference. Notice there's nothing to distribute in front of these parentheses, so I'm just going to rewrite it over. Now, there is something distributed in front of these parentheses. It's a negative. Now, when you distribute a negative, this is going to change the sign. So I'm going to go ahead and make sure I distribute throughout the whole. The whole, what's in the parentheses. So a negative times a positive 4 is a negative 4. A negative times a negative is a positive. So I end up with a positive 2x to the 3rd. And then I just go back and I kind of do the same process as before. I underline everything that's getting plus or minus, so that way I can see the terms individually, and then I say, which one of these can I combine? Off the top, I can see that I have an x to the 3rd here, an x to the 3rd here. If I were to add them, I end up with 9x to the 3rd. And then I have a 4 minus a 4, and a 4 minus a 4 is 0. So should I really write plus 0 there? No, because it doesn't really add any value. Anything plus 0 is itself, so I end up with 9x to the 3rd. So again, this is just a reminder of stuff that we did last week. We added and subtracted polynomials. Now today we're going to multiply them. Now I started off with something that you guys already are pretty familiar with in terms of multiplying polynomials. So if you look at the following, I'm asking you to find the product, aka multiply, right? Because when I tell you to find the product of two things, you're multiplying. Now how do I know what is multiplying here? The parentheses. This is 2 times whatever's in the parentheses. Now, the one thing that you have to remember is that if I am taking 2 and I'm multiplying by everything in the parentheses, everything needs to be multiplied by 2. So what do we call this? We call it distribute, right? And what would be 2 times a negative k? Now, can you multiply 2 and k together? No. So what I like to do when I have something like a negative k is put a little 1 out there, because then that helps me visually see that that's a negative 1k. And if I'm multiplying 2 times negative 1k, well, I know I can't multiply 2 times k, but I can multiply my coefficients. 2 times negative 1 is a negative 2. Unfortunately, there's nothing else that you can multiply with your k, so it just keeps going down. And then you follow the same thing. Make sure everything is multiplied. 2 times 3 is a positive 6. I could go there. I can see that I have distributed that coefficient. I multiplied everything. Now let's go back. Can you combine these two here? No, right? Because just like we talked about before, these are not like terms. One has a k and one does not. So what I want you guys to do is to go ahead and do number 4. I want to I'll explain number 5 and 6 after I go around and make sure that you guys are all good. Yep. Alright guys, so let's look at these two problems together. Now, I know that the directions are telling me to find the product, but if I were to look at number 4 by itself, I know that I need to find the product anyway. How? Because there are parentheses and there's a coefficient without any mathematical symbol in between them. Now, whenever you see something like two things together with nothing in the middle, and I think I've gone over several examples of that, you're multiplying, and you have to have that ingrained in your guys' mind. So let's go ahead and multiply our coefficient by everything that's in the parentheses. Now, a negative 8 times 8p. Now, let me write this a little side note over here so that way we can focus on it little by little. If I have negative 8 and I am multiplying that by 8p, what can you multiply with in this situation? Can you take a negative 8, multiply it by an 8, and get a solution? Yeah, right, because a negative 8 times 8 is a 64. Now, is there any way, shape, or form that you can multiply that times a p? No, right? Because 64 times p, you don't know what p is, so we're just going to tack it at the end just to kind of say, hey, 64 times p. We can't really simplify any further. So don't forget that this was a negative 8, so that means you're going to end up with a negative 64p. And then you want to make sure to multiply everything. Now keep in mind that that sign in front of that 4 is a negative, which is a subtraction. Negative and subtraction are really the same thing. Negative 8 times a negative 4 is a positive 32. Now, you'll notice that I put a huge emphasis on what was going on because this is going to set you up for the other problems that we're going to practice. And this is what we're pretty much going to focus on right now. And this is what I'm trying to tell you. Notice that this time we just don't have a simple number in front of those coefficients. We have a 3p, but I'm not going to let that fool me. I'm still going to take that coefficient of 3p and I'm going to distribute it within the parentheses to find the product. Now, 3p times 4p. Now, I could go ahead and do all the problem, but I want to make sure that you understand why it works out. If I were to write over here 3p times 4p, notice that this is 3 times p times 4 times p. Now let's just take a break and make sure that we know what we're doing. Can you multiply 3 times p and simplify it in any way, shape, or form? No. Can you take that 3 and multiply it by the 4? Yeah, because what is 3 times 4? 12. Yep. Now you have simplified those, but notice you have a p times a p. And what's a p times a p? Now remember your rules of exponents. When you're multiplying two like bases, what do you do to the exponents? You what? Add them. Yeah. Now does your base change at all? No. So your p stays the same. You add 1 plus 1, which equals 2. So make sure that you understand that when you're multiplying the constants times the constants and the variables times the variables, but don't forget your rules of exponents. So 3p times 4p, just like we covered, is 12p squared. Now let's go ahead and multiply 3 times 8. And just like I said, you can only multiply the constants with the constants and the variables with the variables, but don't forget those rules of exponents when multiplying variables. So 3p times 8. Well, I know I can multiply 3 times 8, which equals a positive 24. Now, you know you can't multiply p, but you have to tack it along to kind of just say, hey, it's still multiplying. You can't simplify, but it's there. Okay? All right, just one more just to kind of make sure that there's some understanding. I have 7x. I'm going to multiply it or distribute it by multiplying. Now, notice you have a negative 7x times a negative 5x. Concentrate on those coefficients. Negative 7 times a negative 5 is a positive 35. X times x would be, I wouldn't say 2x, I would say x squared, right? But I knew exactly what you were saying. Yeah, so x squared, and then just keep going. Negative 7x times a negative 3. Remember, the only thing that you can multiply there are those coefficients. So negative 3 times negative 7 is a positive 21. Unfortunately, your x is just really along for the ride. There's not really anything you can simplify by multiplying in that specific term. And you always have to be able to check back. Can you add these two terms together? No, right? Because notice you have an x squared and an x. That's what we were practicing. And notice that this is in order from greatest to least degree. So that is pretty much just all I want you guys to pretty much know between these. But let's step it up a little bit. And let's do a problem like number 7. Because notice now, wait a minute, this isn't exactly like before because I used to have some type of parentheses with just a coefficient, but now I have more parentheses with two terms within those parentheses. What am I going to do? Do you guys remember that special word that kind of will probably jog your memory a little bit? Starts with an F. O-I-L, FOIL. Have you guys heard of FOIL before? No? Okay, well, doesn't really matter. So the main thing that you have to know here is that you have something times something. Now, when you're timesing something by something, you have to make sure that everything gets multiplied. So FOIL is just a way that you can memorize how to do that. Now, FOIL means that the first thing you're going to do when you see multiple parentheses getting multiplied together is start with the first, the very front. 3x times 4x is what? 12x? Huh?
12x.
Absolutely right. Now, the other thing is you want to do the outers. So notice that was front. Now let's do the outers. 3x times a negative 5 is going to be a negative 15x. And then you do the insides. 5x times 4x is a positive 20x. And a negative 5 times, or positive 5 times a negative 5 is a negative 25. Which are the last. Now, I don't know why, but as soon as you say FOIL, it reminds me of the process, but I really don't feel like it helps me remember what to multiply. What I like to remember is I always just take my first term and multiply it by everything in my second parenthesis. Then I take my last one and I multiply it throughout. Whatever you do to help you remember and make sure that you got it correct, keep doing it. Now, so notice that now you need to click that little switch in your guy's head and understand that what we're doing here is that we were finding the product of multiple things. But now notice that we are adding and subtracting a lot of terms. Now, looking at all those 4 terms, is there any ones that I could combine or simplify? Yeah, right? Now, notice that this is 12x squared. Is there any other x squares? No, so I'm just going to bring it down. Now, notice that you have a negative 15x and a positive 20x. Now, those are like terms because they both have x's, so you can add those. Now, keep in mind that when you are adding, you add the coefficients, so you'd end up with a positive 5, but your variable doesn't change at all. And then 25 can be combined with anything else, so you just bring it down. So not only are you finding the product, but you're also adding like terms at the very end. So you're really doing 2 skills into one, and you got to make sure that you click the switch when you're doing each one. All right, guys, so let's do number 8 together. Now, just by looking at these two, this problem, I know that I am going to find the product of 2 different things. Now, how do I know that? Because I have 2 parentheses with no mathematical symbol at the end. So remember that whenever you have this, you can either think of FOIL or you can just do your little arrows. Just do whatever you have to ensure that you slow down and take your time to solve this problem. Now, the way I like to do is I like to take that first term of my first parentheses and I like to distribute it throughout my second parentheses. Now remember, when you are distributing by multiplying. So let's go ahead and take our time and actually multiply what we can and what we can't. Now notice that that's a 7x times a 3x. Now 7 and 3 are just numbers. So 7 times 3 is a positive 21. And x times an x is going to be an x squared. Now I'm going to go ahead and take that 7x and multiply by my last term. And notice I have 7x times 1. So 7 times 1, the coefficient is a positive 7. Now your x can be multiplied with anything, so I'm just going to leave it right there at the end of my 7. Now, just to change colors to kind of make an emphasis, I'm going to take my second term and I'm going to distribute it through my second parentheses as well. Now, 2x times 3x, well, 2 times 3 is a positive 6. Don't forget your x stays the same. X times 1 is a positive 2. Now you can see that I have distributed both. Pretty much everything is multiplied or anything. Now I just have to combine like terms. Now, this x squared, there's no other term with an x squared, so I'm just going to go ahead and write it down. Now, notice I have a 7x and a 6x. Now, those both just have x's, so I can add those. 7 plus 6 is 13. Don't forget your x. And then your positive 2 just gets tacked on at the very end. So that is literally how all you have to do. So we'll do one example just so that way you guys can start with your guys' work today. Now, I have a problem here that is 2 parentheses next to each other without any symbol in the middle. So I'm going to multiply them. I'm going to start with my first term. 2r times 2r, well, 2 times 2 is 4. R times r is r squared. 2 times a negative 3. Well, 2 times a negative 3 is a negative 6. Don't forget your r is just really hanging out. 1 times 2r is a positive 2r. And then 1 times a negative 3 is a negative 3. Now, this is 99% of the time always going to work out where your middle terms are always going to be able to, they're like terms, they're going to be able to be added, especially if you follow the same pattern. So let's go ahead and add those. Negative 6r plus 2r is a negative 4r. Don't forget your negative 3. Everything has been combined and you are good to go.